For question 7, I'm asking you about road density, and you guys really hated this question, it seemed like, in class. The first thing we're going to do, though, is go in and inspect the extent of the data, and right away you should see there are some municipalities that we need to get rid of. We shouldn't be trying to calculate density for something that we don't have full overlay of our data set for. Yeah, so I would say a few of these need to go. And we can do the same thing. This time I'm just going to go ahead and delete them because we don't need this for the next question. All right, open the attribute table here. Just verify that I have 3 selected. That's what I was basically going for. And yes, I want to delete those and then save. Okay. Right, so now we've got municipalities and roads. And what I'm asking about here is density of roads. This isn't road segments, so it's not about getting a count of the roads per area. The density would be the length of the roads per municipality area. That's what I'm looking for. So if we zoom in here and just see if we can get a sense for what I'm talking about. You can see the density here is much higher than this guy here. It's the length of the roads relative to the municipality. The first thing we need to do is get rid of all of the municipalities that aren't the county seat. And if you weren't sure what this is, you can Google it. If you don't know what a county seat is, you could also look at one of these. So this is the city of Monroe. You could Google, is Monroe, Utah, the county seat? Or you could Google what's the county seat for Beaver County or something like that. So there are ways that you can just reason this out, but there is also, of course, a field that tells us which municipalities are county seats. It is a binary kind of true-false. And again, if you don't know, if 0 is if 0 is county seat, or if you don't know, then Google it. Is Nephi, Utah, oh, I hope I'm saying that right, sorry. Is that a county seat? If Google says yes, then we've got our answer. All right, so let's sort this descending and get all of our county seats together. And because it's me, I'm going to go ahead and just make a copy of that. And yes, you can also do the selection method and make a layer, a temporary layer from the selection. That's fine too. It's probably a lot cleaner, actually. Input features, we've got 11. That sounds good. And CS for county seat. Okay, and this is what I was talking about. If we go in here, you can go to selection and make a layer from the selected features. So this is a temporary drawing, but you should have full utility of those. Like you should be able to buffer or clip or whatever else with them. But when you close the program, they disappear. Okay, well, anyway, we've got our county seats now. We don't need the full municipality. We just want to be working with the county seats. Okay. And we've already gotten rid of all the ones that fall outside our road layer. So we should be good to go to combine these two data sets together somehow. Now, how would I do that? I would, of course, think about clipping first, because we need to actually end the road segments where they intersect with the edge of a municipality. I don't know, maybe they all already clip there, but I know it's going to be, it's going to be easier for my brain to just know that I've cut them, so that, see, this one does cut at the boundary. Whoopsie. This one does not. So not all the roads are automatically segmented at the boundary of the municipality. So we do need to either clip or intersect these. Intersect is going to allow us to keep, intersect will allow us to keep the municipality name attached to the road, which might be really helpful. So let's try it that way first. So clear my selection, go in here and run intersect. Okay, that works. We're going to input the county seats and the roads. Okay, output feature set, that looks good. And all attributes, same as input, yes. When you choose same as input, it defaults to the simpler geometry, and in our case, that's the lines. Points are the simplest, lines are second, and polygons are the most complex of the three. So we can turn off our inputs and just look at the output, and that looks right on. Yeah, okay, looks good. All right, so now what we want to do is get a length for each of these road segments updated. Easy to do, attribute table, we can either add a new field, or if there's something that we don't mind overwriting, we can just use that. So let's see what we've got here. Got a shape length here. Let's see if it'll let us calculate geometry. It will. So let's update this and put it in meters. Okay. Yeah, it looks like it did update that quite a bit. All right, so we've got a new set of lengths for each one of our chunks of municipality. But what we want to know is which municipality each one of these road segments is in. It looks like our road segments are here at the end, and the beginning stuff is our name here is the city name. So we're going to use this, and we can calculate summary based on these now that we have an updated length field. I'm a little, let's see, FID roads. I'm pretty sure this length, let's test these. Let's find this guy. And let's measure across that and make sure it's about 160 meters. Imperial. Okay, so that's right on the money. I feel good about that. So this is going to work for our shape length field, and then we just want to basically summarize those lengths, sum them based on the name of the city. This is going to help us get, actually, you know what we could do is a summarize within and summarize these lengths, and then calculate, because what we want to do is divide those lengths by the area of each county. Okay, one more time. Float means floating point. This is decimals. Float will take any number you throw at it, positive, negative, and as many significant digits as that we can even conceive of. If you go with double, that also works, but I tend to use float. Short and long are integers. The short integer will accept up to like 52,000 something characters. You have to be careful with these because Like if you're calculating areas of really big things, you will end up with a certain number of digits, but then it just can't store anymore. So your numbers are technically wrong because you might be missing orders of magnitude. So I tend to just go with this because storage of attributes is not really a big deal with the data that we work with, but just as a little reminder, there you go. Let us, okay, let's try using the summarize within. This is definitely not how I did this the first time around when I set these questions up, so we're just going to experiment. But it seems like a good idea. Summarize within would be equivalent to the zonal statistics, but for vector data. So our input polygons is pretty obvious that that's our county seat municipalities. The features that we want to summarize would be our intersected roads, the ones that have been cut at the boundary. And because we recalculated the length, we're good there. Our output feature class is a big, ugly name. The field that we want to use was that first shape length field. And when I calculated it, I noticed that it had the repeat. The statistic, we want the sum of those lengths. And shape unit, I almost skipped this, or would skip this, but reading the identify tools, it says that if linear unit, okay, so if you have a line, then you should pick the length unit. And so we are definitely going to convert this over to meters so that we're being consistent. Group field, what's that? An attribute field from that's used for grouping. So this is kind of like the zonal statistics. This is like the zone field. So this would allow us to group things if we wanted to, meaning we could have used this tool with all of our municipalities, and we could have set the group field equal to, what was it called? County seat, right? And then we would have gotten one summary. Oh, it wouldn't have broken it down though. It would have just compared the road density of county seat municipalities versus non-county seat. So that would not work for us here. Anyway, let's go ahead and give this a run, see what happens. All right, it gave us our output data set here. I'm going to open the attribute table and see what we have to work with. So we only have 11 rows or features, and that seems like really good news because it seems as if that's probably how many municipalities we have to work with here. Let me go over to my select tool. Let's see here. Yep, okay. We had 11 to start with, so that's very good news. What's next? We want to know, what have we got here? The summarized length in meters. I love this. This is amazing. Here's a count of the lines. So this would be how many line segments are in each one of our municipalities. But here's the summarized length. I'm going to sort this ascending and see what the smallest length is. It's about 20 kilometers. Let's go to this guy and see if that seems true. It is definitely a little tiny town. And if we measure across it, that's about a kilometer. I would say 20 kilometers is pretty much right on the money. So I think this looks pretty good. So here are our different lengths for each one of our cities, right? And because we're back to polygons, now we can calculate the area or verify our areas. I'm scrolling over to see if I've got a shape area. I do. All right, I'm going to overcalculate this. No, I'm not. I'm going to add a new field and call it area. We calculated all of our lengths and means. I'm going to go ahead and make this square meters. Okay, save that. Close it. And then calculate that over again. I cleared my selections. Oh, come on. Where am I here? Here I am. All right, calculate geometry. Yep, meters squared, area geodesic, looks good. Okay, now we have an area for each city and we have a length of road for each city. This is a tricky one. Let's set up a field calculation for our density. So what we're going to do here is add a new field. Call it road density. And save it and close it and scroll over to it. And so this is a field calculation because we're calculating between two fields. We're going to divide the road length. So we're in this table, we're in this field. We can skip that, and we know we want our length, summarized length in meters, divided by our new area. So we're getting length per unit area, and that'll be our density. Okay. They're pretty small numbers. Sort it descending, and it's telling us that the most dense municipality is Richfield, the city of Richfield. So let's zoom to this guy, and we'll take a look at a few of these just to verify that we're getting results that make sense. Yeah, okay. I mean, we've got a lot of areas that don't have roads, but the kind of duplication of the freeway coming through here probably adds a lot to the density. There's definitely a lot going on there. And let's go halfway down. Yep, definitely looks less dense. And our least dense. Yep, I buy our results for $100. So we came up with Richfield as our most dense, and I would guess there's probably quite a few ways to do this. I know I did it a different way when I first set these up, like I said. Can't remember how I did it, but I haven't really come to terms with Summarize Within yet, but I've seen you guys using it a lot, which is great. It's definitely a new tool, and it's going to help me be a lot more efficient. So I do appreciate that you guys dig and find creative and unique ways to solve these problems. It helps a lot. It helps me learn new ways to do things as well. So, okay, so let me brainstorm here for 1 second and see if I can think of another way to do this. I can't think of the other approach I took to this. As always, if you feel like you've got a legit approach, or if you can't figure out why your approach didn't work, just let me know, and I can start collecting PDFs from y'all. All right, last question coming up next.